Hey guys, it's Matthew with Cotter Industrial. We're going to talk about the pros and cons about using belt drive ReDrive systems for your experimental airplane. Here we have the Opti Belt Omega HP. This is an 85mm wide belt with an 8mm pitch. Now, the great thing about the Experimental Aircraft Association using experimental category aircraft is that you can move into engines that would relatively, cost you an arm and a leg. You could use a traditional air-cooled Continentals or Lycoming engines and be spending, 15, 20 grand for anything that makes more than 200 horse. In the automotive industry, you could pretty much get a comparable motor for less than about $1,000 depending on its condition and use. So naturally, when using an automotive engine, the point of these engines making that power actually requires a much higher RPM, almost double that of a Continental Lycoming motor. Unfortunately, propellers are not designed to run that fast. So in order to get the 230 horse from this motor, we need to be able to spin it up to 4,400 RPMs. And to get the maximum horsepower, we need to bring it up to 6,500. So, we really need to get those RPMs up in order to get the power output. However, most props are only designed to run up to 2,500, sometimes 3,000, depending on the engineer. So that brings us to ReDrive Systems, and those are reductive drive transmissions. Now you have a few options out there. You can use Planetary gear system, sprocket and chain system, or in this case, we're going to use a belt transmission system. Now, these transmission systems are well known and famous in the Top Fuel and Funny Car Drag. These particular belts are actually used in powering superchargers. Now, you would think that maybe that blower wouldn't really require much horsepower. However, if you were to look it up, to get that 8,000 to 12,000 horsepower, that 1471 blower actually requires almost 1,000 horsepower from that motor to get the boost they need to make that 8,000 and 12,000 horse. Now, in reality, you're not going to get a geared transmission to put out that kind of power without it costing you a whole lot of weight. So the race organizations such as NARHA came out with the belt drive systems. So this particular belt system, which is well known in the racing community, is an 8mm pitched belt drive. Now this uses a high torque type of belt. It's not your standard industrial belt. This is specifically designed for high torque applications. So one of the major savings in these belt drive systems is not only price point, it's weight, plus you're minimizing harmonic vibrations from your engine to your prop. And guess what, guys? That opens you up to a whole new ball game when it comes to propeller selection. So in most cases, when you use a planetary gear system or a direct drive system with your engine, you have a lot of downsides to that. So if you were to ground strike, you're talking about a complete engine breakdown, sonic and die testing your crankshaft and all the internal components to your engine to make sure that when your prop strikes the ground, it hasn't damaged the internal components of your motor. With a belt drive, chances are that belt's going to break long before that shock load actually gets to the engine. So it's a whole lot better to replace that prop and your belt drive than the whole motor itself, essentially. On the other hand, other advantages to the belt drive compared to gear and sprocket systems with the chain is that you get other options for propellers, as we spoke of before. So when you're going with a direct drive, you're basically limited to aluminum and wooden propellers. Now that's kind of a real bummer because in reality those are heavy. They have a lot of limitations what they can do. The pitches are fixed You don't have any variation. Now, you do have constant speed aluminum propellers, but you're talking about a huge amount of weight. And obviously, the more weight on the end of this motor, trying to rotate that prop, the more horsepower is going to be required, and it's going to basically be just a parasite on your engine performance and ultimately aircraft performance. When going with a belt redrive system, guys, you are opened up to a whole new ball game. We're talking about fiberglass and carbon fiber propellers. Now, when you're using a carbon fiber propeller, you cannot use them on a direct drive with an automotive motor or even a Lycoming and Continental motor. And the reason is because those harmonic vibrations go through the crankshaft into the propeller and cause microfractures within the resin, and ultimately your propeller is going to break off and fly off your plane, and you're going to find yourself in a quick scramble to find a place to land your plane before you hit the trees. So back to the belt drive. We're going to go probably with a carbon fiber propeller. I've made a rough idea selection as to which one I want. I'm narrowing down a couple of their options. Availability is also an issue. Now, we're going to go with ultimately a carbon fiber prop. Okay, and the advantage of that is that carbon fiber prop is only about 5 pounds. So, considering a 3-bladed prop, we're looking at about 15 pounds all together. And then hub assembly, you know, so it just kind of depends which hub I'm going to select for this one. I've thought about machining my own hub, but unfortunately I need a much higher precision mill machine. I can't do it myself, and the local machine shop actually went out of business. So I may have to send that one out of state or to a bigger city that has access to the proper equipment to make the hub I want. But for now, the propeller company that I've selected, they do provide fixed pitch hubs that I can adjust on the ground. Sorry about that focus, trying to get it going here. So they actually give me options for fixed pitch, but I want to make it constant speed ultimately in the end. So we will do that upgrade later on, but for now we're talking about this belt drive. This particular belt drive will allow me to transmit 230, and actually it's engineered to 280 horse, so 285 horse, and that gives me about a 1.5 engineered application. So that way I have a little bit of leniency for this particular motor here. So obviously we may want to upgrade later on, and all we gotta do is basically double up the sprocket, expand the transmission case, and here I can get up to about 450 horse. Now ultimately I would like to put a supercharger on this thing so I can go up to 18,000 feet, but for now we're going to kind of stick it down to about 12,000 feet naturally aspirated. So always have a second belt on hand, because you know, you never know, you break something out there. It's a whole lot better that you land off site and be able to swap the belt out. This particular belt is designed to run 8 to 12 hours a day for a full 5 days a week. So that gives you about 20 days a month times 12. So it's basically a whole lot more flying than I'm ever going to do. I don't fly as much as I'd like to, of course, and with weather here in Alaska, you just got too much stacked up against you. So anyhow, guys, run up on the time. That's basically the pros and cons of the belt drive systems. You know, obviously maintain proper tension. You know, a lot of guys out there, they kind of shine away from the belt drives when you consider larger motors, and the reason behind that is because you don't have the proper tension. You have to properly engineer. These belts are properly engineered for very specific applications, and you have to conform your transmission application, your engine and your transmission application to the specifications of the belt itself. Okay, so I've seen guys out there running Gates belts, and they can hand slide these things in and out. Okay, if you can move this by hand in and out, I guarantee you, your tension is completely off. Okay, a lot of guys that come up and do kind of the old-fashioned finger push thing, oh, I got about an inch and a half of play there. That's not right. Okay, and I'm going to tell you a little secret about properly tensioning these. You don't have an adjustable tensioner. Okay, you put in a spring-loaded tensioner that will maintain a constant pressure on this belt. Now, every belt drive is going to be a little different, and a lot of it's based on the sprocket size, the engine performance, as well as the centers, the distance centers between the two sprockets. In my case, for a 44 tooth and an 80 tooth sprocket, I need about 72 pounds of pressure pushing across this belt constantly. So what I'm going to do is I'm going to actually put in a spring-loaded tensioner on here, a lot like what you would see in a standard belt drive timing belt system on most of your engines. Every engine that uses a belt drive or belt timing gear system has a tensioner in it. They don't just push it down with their fingers. That's good enough. No mechanic would tell you that. So anyways, guys, I hope you like this. I apologize for the focus. It's really lousy. But, you know, if this is informative, educational, and, you know, maybe you'd like to get a transmission from me, just go ahead and smash that likes button. Don't forget to subscribe, thumbs up, and smash that bell so that next time I put out a video involving this kind of stuff, you'll be the first to know. So take care, my friends. Enjoy, and don't forget, fly safe and keep safe. Stay away from them COVID zombies. Take care, my friends.